Bismillahirrahmanirrahim. Assalamualaikum and good morning. I back to lecturers, students and audience. So my name is AIman Fitri bin Shahrum and my message number is 598590. So today I'll be presenting my e-poster for my final year project entitled Design of Flexible and Stabilized Triple Wheel Electric Unicycle as Micro Mobility. So as you can see on the screen, these are the poster for my final year project. So in the poster, I'll be including the introduction, methodology, results, conclusion, and application. Okay, so we go to the introduction first. So one of the micromobility vehicle on the list is the electric unicycle, which is propelled by an electric motor that is powered by a rechargeable battery. So this electric unicycle movement and direction are controlled by the angle of the rider's body, in which we can say if the riders are leaning forward, then the unicycle will accelerate and moving forward. And if the rider is leaning backward, the unicycle will decelerate and will be moving backward. Okay, so however, the original electric unicycle still has a significant problem with the lateral stability, which means the stability of the right and left angle. So project from the previous final year have proposed a new adjusting part and mechanism in order to make sure that the electric unicycle can reach its maximum lateral stability. And as for this project, new part has been introduced, which is the linear motion bearing to reduce the friction of the sliding mechanism between the main chassis and support chassis. So in conclusion, this study is helpful by equipping the existing part and adding of linear motion bearing help to improve the sliding mechanism between the main chassis and support chassis of the electric cycle, hence improve the stability of the electric unicycle itself. So next, we will move on to the methodology for this project. So these are the flowchart of the activity for the final year project. So first, we start by identifying the problem statement, which are said before, the lateral stability of the electric unicycle itself. And then we move on to objective stated. So the objective stated in the thesis of the final project. And then research and data collection. After that, after we get the data collection and research, we generate idea to make the new stabilized design of the electric unicycle. And then we finalize the idea, and then we develop the best design out of the idea generation before. And then from the design itself, we develop a prototype. Okay, and then we check and validate whether the prototype is good or not. So if it is not well done prototype or not good and have a problem, we're gonna fix that problem and we redevelop the prototype, and then it is the end of the final project. So we go to the results. So for the result, it is mainly focused on the simulation result of the critical part in the electric circuit itself. For example, the support chassis, main chassis. So we must simulate and analyze whether this part are strong enough to hold the load, I mean human load, which are we put the maximum as 135 kilogram. So if we check and simulate, if the part are okay and not have any major deformation, so it is good to go for the development of the prototype. So for the first result, I will show the equivalent stress for the support chassis of the electric cycle. So this is the support chassis. It equivalent stress at the 165 megapascal, which is lower than the material used to develop the electric unicycle prototype, which are the structural steel. So it is good and no major deformation in the support chassis. So we go to the main chassis. it only have 4.5 megapascal equivalent stress. So this shows that the design of the main chassis and support chassis are really, really strong. And it is really suitable for human, I mean for individual ride for the electric unicycle. So these are the final design of the electric unicycle. So we have the support chassis. These are the support wheel that attach to the support chassis. These are the main tire. So we have the pedal to place both feet and more. Okay, next we go to the conclusion. So the new component is added, which are the linear motion bearing, can reduce the friction and give a greater smoothness to the sliding mechanism between the support chassis and main chassis. So it automatically improve the stability of the electric cycle itself. So the strength of the component and part are identified to make sure that it is very durable and safe to use. And then the prototype have been successfully fabricated and tested. But however, sliding mechanism cannot achieve the maximum smoothness because there was a mistake during the material selection during the fabrication process. So this is the application. Electric cycle can reduce the time and energy consumption for individual from one place to another. So that is from the society aspect. So in terms of the industrial benefit, maybe we can use the electric cycle in the factory to make the workers move faster and improve the production rate of the factory itself. So I think that's all from my final year project poster presentation. Thank you very much and Assalamualaikum.